All right, so I've got another arc length formula. This one here isn't a nice, neat little straight line that we can solve for. This section says solve for the integral exactly unless you're unable to, like there's going to be some crazy ones in those that you need to approximate. I'm going to choose ones that you can use. So I've chosen 173 here, which isn't something we can actually integrate by the end of it, but let's see. That'll work. So we want the arc length of this going from 0 to 1, 0 to 1. Well, we can do it like this. So that's going to be 1 plus this whole thing, this 1, I guess the derivative of it. And that's going to be d dx of 1/3 times the quantity x squared plus 2 to the 3/2. All that is dx. Well, let's do something real quick here. So if we have 1/3 x squared plus 2 to the 3/2, the derivative of this is 1/3 times the quantity 3/2 times this whole x squared plus 2 to 3/2 minus 1 is 1/2 times, using the chain rule, times what's the derivative of the inside, which is x squared plus 2. The derivative of that is just 2x. So our 3's cancel, and we've got, and our 2 cancels with the 1/2. So this is just equal to x times the quantity x squared plus 2 to the 1/2 power. So again, from 0 to 1, and we're looking at 1 plus this x times x squared plus 2 to the 1/2 power. Well, and actually all of this, pardon me, this is squared and this whole thing is squared, right? It's part of our formula. Okay, so let's do the squaring on that. Well, we've got x squared times times just x squared plus 2, because we have to square each of these parts individually. So we square x, that's x squared. We square the square root of something, it just becomes itself. And now let's, I guess, do a little bit more work here. This is x to the 4th plus 2x squared. Now this factors. So let's choose yet another color here. All right, so if we have x to the 4th plus 2x squared plus 1, that's the same thing as taking x squared plus 1 times x squared plus 1. If you do the FOIL on that, you'll get what comes up, which is the same as saying x squared plus 1 quantity squared. So this is the square root of x squared plus 1 quantity squared. Now we're taking the square root of a square, and I'm sorry, this goes from 0 to 1. Can't see it, so I'll bring it down here. So this is just the integral of 0 to 1 of x squared plus 1 dx. And this is something we can do. We do each one individually, so we're going to evaluate this. The integral of x squared is going to be x cubed over 3, or 1/3 x cubed if you prefer. And the integral of 1 is just x. We're evaluating that from 0 to 1. Well, the zeros are going to cancel it out, so this is just going to give us 1/3 plus 1, which is 4/3. And we didn't need to use any sort of program to approximate our integral in this case. So this, again, this is an arc length. This isn't one that we could even solve with the Pythagorean theorem or anything like that, so one of the more difficult questions.